Okay, so as a small recap, yesterday I have made a start on an assembler for the Game Boy, specifically to create Game Boy ROMs. And it was a very slow start because instead of using the C runtime, I wanted to use the Windows API, which I'm absolutely unfamiliar with. So try to do a few things with that. And so far I managed to open up a file, uh, read the whole file out into an 8-bit buffer, basically. So basically in bytes, read single bytes out of that file, and have been iterating through every byte in that buffer, um, interpreting it as an ASCII character, and trying to tokenize it. And we sort of got a simple tokenizer ready. We can recognize a few tokens such as spaces, new lines, words, separators. And I have not got made a plan for today, uh, so I'll just open up the code later on and see what I can do. Um, I have been using, well, so at the moment as my dev machine I'm using only Windows. I have been using Linux in the past. In fact, I have been trying to run Linux as my main OS for a year, and that did not go well. Let's put it that way. I think Linux is doing a few things right, right? So running command line applications from in there and like coding on Linux is actually quite a nice experience. But if you're trying to do anything else, it's just absolutely horrendous. At least that was my personal experience with it. Um, no, so as my main OS, I'm actually using Mac OS, which is where I do most of my daily driving, video editing, and all this kind of stuff. And then I have this Windows machine right here, which is for, well, mainly gaming and programming. Yeah, the command line is definitely better. But, while I do code command line tools right now, I actually do not prefer them. Um, I would like to have like nice UI tools for everything. It's just, command line tools are incredibly easy to code and you have quick results, which is nice, which is why I'm doing this on the stream, especially if I'm trying to learn something. But eventually I want to be able to do some UI stuff. But yeah. I can see why people prefer command line, to be honest, because it's just so incredibly flexible, right? Um, you can just have any input and redirect the output from one application into another and sort of do this whole mixing of application and chaining of applications, which is absolutely amazing, right? And I do not understand why this is not being translated into the UI world. So every UI application on any operating system is trying to be like its own island that controls everything, which is just so bizarre to me. Um, there needs to be something done to like make UI applications a lot more flexible and actually be able to talk to each other like a standardized input output something on the OS level. Like that no one has even attempted this. It's just so bizarre to me. And this is where command line rocks, right? This is where any terminal application rocks. It's just my 2 cents on that. I'm sorry. Okay, let me switch to the machine. And let's have a look at what we did so far and have a little bit of a think of what the next steps will be. So I definitely want to make this nicer, this GBI next token. And I'm not sure I like this separation of like the token type and the token info. I've sort of been treating this as like a stream of tokens, right? Where we just iterate over this in the while loop and get like the next token. But later on, when I actually want to look, well, basically when I want to parse the tokens, what I sometimes need to do is either look backwards or forwards from the current token that I have, right? And sometimes you just want to peek forward, but you don't actually want to consume that token. So having like the stream is a bit, it makes things a bit more difficult. What would be nice is if we just maybe have, let's say, an array of tokens, where we just shove in all the tokens for one line. And then we can just have, you know, based on the index we're at, we can then look backwards or forwards depending on what we need at any given time. So I'll probably change that to have like a token buffer where I just write the tokens in. A lot of blue screen errors on Windows. Surprisingly, I didn't have them. So I was a Windows user for pretty much most of my life, right? Except I've never done Windows API programming really, which is, I went down the C# route kind of things. And I never had much errors with blue screen on Windows. But what I did have was a lot of graphic card driver issues and all this kind of stuff. And I had black screen issues, basically. So the screen would just go black, or sometimes it would just freeze. The whole operating system would just freeze and nothing would work, right? And it got me so mad at everything because, like, it was a new machine. I built everything, I installed everything, and then it just made me so mad that I gave my PC away essentially and just bought a Mac and was like, no, I'm not dealing with this shit anymore. I don't want to. I just want a machine that works so I can do my daily work with it. And so far the Mac has been fine. I agree they're like shit ton expensive, but at least sort of they have all other kinds of problems, right? I'm not saying it's like the perfect machine or anything, but at least it has been working for me quite fine. But recently I found myself wanting to go back into programming, and programming on Mac is, oof, I don't know what Apple is doing, man. They seem to be deprecating things left and right and changing how things work like every 2 years, and it's just like, who wants to keep up with that sort of thing? So I have to actually commend Microsoft for being able to, I can just still use C and use all the APIs and it just still works perfectly fine, right? That's the way it's supposed to be. I mean, Linux is going sort of in the other direction where they even support like teletypes from God knows when. I don't think that's necessary, right? They're being too backward compatible, but it's fine, I suppose. At least there's something for everyone out there, I suppose. Plus, you know, you can't beat a free operating system. I mean, if you don't have money for Windows and it didn't come with your PC, why spend money on an operating system when you can just install Linux, right? I mean, it makes perfect sense. I was just lucky enough that any PC that I bought back in the day came with Windows, so I've just been using it ever since. Anyways, yeah, so I think one thing I can do now is because there will be a lot more token stuff involved, so I'm gonna put that in its own header. Let's call it GBA token.h. What did I name this? I forget. Oh, this. Okay. And what do we want to do? Let's put this next to us. So I guess I definitely want these type devs over here. And the file is fine. New line, white space, separator, comment and word. Cool. Gonna take this one over. And instead of token info, let's just rename it token, because I actually want to have both of these and let's have the token type in here. Cool. So and then we have this next token thing. So let me think about that for a bit. Well, let's copy this in here first. Right. I mean, I can already do the definition at least of the function, so to sort of give me an idea what I actually want. So what do I want? Well, I suppose I need a boolean, right? stdbool.h, because, well, either we're having tokens or we're having none. And what I want to do is GBA get tokens of line. Or read line tokens. I don't think I actually want a bool, to be honest. Because what are we going to pass in? Well, we're going to pass in our GBA buffer, right? And well, let's not pass in the GBA buffer. Rather, right? We have a pointer to the bytes where the tokens live. what information is in the buffer again? We have the capacity and size. I think that makes more sense, right? No, okay. Let's change this the GBA buffer. I think that was correct. That was okay, right? I mean, we already made that type. Let's use it. So this will be in GBA buffer.h. Include GBA buffer.h. Let's make this void for now. Okay, so we pass in the buffer. And we're just getting the tokens for a single line. So we kind of need to figure out where the line starts, right? So this is where we can use an offset to know where in the buffer we actually want to start iterating from. And then the output that I want to get is gonna be what is it going to be? It's going to be the tokens. And what we probably want to specify is the max tokens, right? So this will be the array of tokens, but we also need to specify how many items we're actually expecting, and if we have more than these, then we probably just stop with a parsing, because, yeah, why would we continue? And we do not need to set a length for the buffer because the buffer already carries that information, right? We have the size and the capacity. I'm not going to be overly defensive with the offset anyways. So, but here's the thing. Now, instead of a bool, I should probably return a size t, because I kind of need to know for the next iteration for get tokens from line where the last line ended. So this needs to return the new offset, essentially. That sounds about right to me. Okay. So, and how do we envision this code to be? So these are like single line tokens. We find them and that's it. So we can just add them to the tokens buffer. Then we have line endings, CR, where there potentially might be 2 characters involved, but that's not that big of a deal. We just look ahead 1 byte. The more interesting ones are the ones down here, where I need to find certain characters, right? So here I'm looking for line endings. Here I'm looking for anything that isn't a white space. And then here I'm looking for basically any of the special characters. So I think it would be a good idea to plug these out into separate functions. Yesterday I was alluding to like maybe having like a generic thing where I can pass in an array and then like for terminating characters, but I think I'm not going to do that because having them just like separate functions like this gives the compiler a bit more chance to maybe optimize this for us. And we want to be friendly to the compiler. So let's do that. Okay. So for now, let's just return all. To do. Implement me. Okay. So what do I want? I want something that looks for line endings. So really what I want is the index of line endings, right? Find end of line. And where we're finding the end of line of that, I'll decide in a second. Okay. So, and I'm gonna start from the offset. And if offset is smaller than buffer size, then we just increase the offset. We fetch the next character out of offset. And I have these line endings definitions right here, right? So let's just plug them out, put them in here. Actually, let's make this a switch. Now we can make this a switch because we can actually return out of the function and don't mix this up with the other switch statement. You know, it's a bit awkward when you have a break here because like, does that mean you're breaking out of the loop or breaking out of the switch, or like it can maybe be confusing. I don't know. So anyways, so we're fetching the next character on the offset, and if that character is a line ending LF or it is a line ending CR, then we can just return the offset. Correct. I mean, that's what we're... Yeah, that's what I'm doing right here as well. Cool. Okay. If we reach the end of the buffer, then that probably means it is the end of the file, because the whole buffer contains the whole file. In which case, the last line won't have a new line character, so I can probably just return offset as well. Because technically that's the end, so that's absolutely fine. I like this little function. Nice, simple, clean. That's what I like about C so far. Okay. Then we have white spaces. GBI find end of white space. And I also need the offset because I need starting position. And same again, we begin at the offset, just increase it. Then we have does that make sense to change it to a switch? Probably not. This is fine like this. So we are looking for the next character, and if the next character is not actually, there might be more white spaces, I just remembered. If we're starting to look into Unicode ranges and things like that, so maybe let's do that as switch as well. Well, it's kind of going to be inverted, so I have this, and okay, let's make defines for these as well. Let's call this char. And have it like this. And then this would be tabulator. Nope, 0x20 was space. Find char space. I mean, I don't really need that, to be honest, so that's fine. So char line ending LF, char line ending CR, then we have char this and char space. We do nothing when we encounter those, and on anything else we return the offset. And if we have white space all the way to the end to the file, let's return the offset as well. Okay. Should have this to do here as well. And then we have size t, GBA, find next special character. find next token character. That's probably more correct. GBA buffer T buffer and size T offset. Cool. And here we can do a switch as well. Okay, so and we have comment and space. Okay, so find char s and what did I say? Oh, separator, right. Just do that. Okay. So we have both line endings, tabulator, space, semicolon, and the comma. Cool. If we encounter any of these, return the offset. Otherwise, we go all the way to the end. Return offset. Cool. So these are the main three search functions that I'm gonna need. Okay, what I'm probably gonna need is an token index, which will be at 0. Then we have a for loop where we go from the offset again, and then if offset is smaller than buffer size, then we increment the offset. And then a ginormous switch on the buffer data offset. And I basically do the same thing as here before. So if I need these up here. Actually, let's call this token. Those names are a bit of a mouthful, but whatever. Oh, no, this is... Okay. Should have used Visual Studio's tools to rename them, but whatever. White space tab, white space space. Okay. Yep. Then we have comment, yeah, and the separator. Okay. So if it is a comment, okay. Let's just prepare all of these. Okay. Let's just do it this way. And then the default case. Actually, let's do the default case first. So there we would call this one find next token character. And what we would pass in is, again, the buffer. But the offset would be the offset +1. Right. Because whatever character we found now, good afternoon. Whatever character I found now, we just want to advance and yeah, basically find the end of it. Okay, so this would be the end, which basically means let's see, we have token index. Doing fine today. A bit tired, but otherwise fine. How about you? So token index. And the end of that token, we can basically set it to this. Actually, maybe how about we keep the pointer to it? GBA token T, current token. And the current token is tokens, well, just tokens because we're looking into the first element, right? So really I can just do tokens type equals GBA token type word, and then tokens start would be the offset, I think I can set the start in the beginning of this loop, right? Because I have all the searching being done in separate functions down here, right? So it's essentially like a little state machine where we go into a different state. So on the beginning of this loop, I can always do this. And here I set the type. And then the end of that token. Right. Actually, offset can be set to this as well. I don't like this. Let's think about this for a second. Really what I want is a while loop, right? Essentially. So while offset is smaller than buffer size. Okay, let's do it like that. And then token start would be the offset. Then we find the end. And then the next offset will essentially be the end of the previous token that we found. Yeah, it is kind of fun. So for any first-time watchers, let me just tell you, I am very interested in, trying to learn how development tools have been written. so I just wanted to start writing my own, essentially. And so that means an assembler, disassembler, an emulator at some point. So I want to go through all these tools and see if I can write my own tool chain to write software for the Game Boy. Why the Game Boy? Well, because it's simpler than any other CPU out there, right? And it's also quite limited in all the input capabilities and stuff like that. But I think whatever I learn here is quite applicable to some other things as well. Chip 8 is this kind of little open, I'm not sure if it's open source, but it's like this little emulator thing, right, where there's no real device attached to it. It's just like this virtual machine, essentially. Yeah, I mean, that would be fine as well, but I kind of wanted to, do it with real hardware and see how I can get on with that. Chip 8 is really cool, though. I've seen some people build some Chip 8 devices with like Raspberry Pis and stuff like that, which is quite cool. Okay, so working on a 2D, 3D engine. Nice. I love when people write their own engines. I got like really obsessed with game engines earlier in my life as well. The problem is I got so obsessed that I started to write engines and forgot about writing the game, and then you kind of never shipped anything really, which is quite bad. So make sure when you write an engine, write also a game that you can actually ship with it. Okay, so tokens, and then we need to advance tokens, right? Because we want to point to the next element. So what we should probably do is, well, we have token index. So we can increment that. And then if token index is smaller than max tokens, because that will be the end of the buffer, then we can advance tokens by 1 position. Actually, really, if you think about this, this is makes no sense, right? Really, what this boils down to being is a for loop over the token, the token's result. So what we're having is size t. Let's say I, we start with 0, right? If I is smaller than max tokens, because we're trying to fill the buffer. So I actually like this more, yeah. And then for every single slot in that token buffer, we're just trying to figure out what the next token is. By also going through that, right? So really tokens I start equals offset. Then we're looking at the first character and trying to figure out what kind of type this is. can do it as such. Right. And then the next offset really will be tokens I end, which is fine. Side distance fields are fun, yeah. Good luck. I've not dealt with SVG before, so I'm still stuck in the bitmap era. Probably always will be. Anyways, okay, we have that. Okay. However, when we encounter a new line, we need to break out of this, right? Because the line is finished. Hey, don't apologize for terrible English in advance. I kind of have a bit of a funny accent as well, so it's fine. And mispronounce words. Because English is not my first language. Shocking. Okay, and if we actually reach the end of the buffer, we won't have a new line, but that still counts as our line is finished. So we probably need to indicate this somehow. And luckily, I mean, we do have an end of file token, right? So we should just set that one. So really what we want is to put this out of this loop, because we're going to access it down here. No, does that make sense? No, hang on. If I is smaller than max tokens and offset is smaller than buffer size. I kind of don't like these mixed. Oh dear. What do we do here? So I figured I probably do not need to return the size because I know where this line ends based on the last token, right? So, and really what this means, whoops. Let's remove this for now. So if I'm breaking out of this, what it means is we have possibly more tokens than there is space in the buffer. So right, so and return false. But then also, if we now are at the end of the buffer, we kind of want to break out of this. So, but that would still be valid. And since we're setting the offset there, what we should do is okay, so if offset is bigger or equal to buffer size, I'm not sure if it can actually ever happen. Now I'll just check it here. So if offset is buffer size, then we are done. Okay. So then we have white spaces. And let's make this a bit nicer like this. Okay, tokens, type would be GBA, token type, white space. And the end would be GBA find end of white space in the same buffer, and the offset +1. So if we find the end of the white space, then we're setting that as the new offset, and if we still have space, then we just continue, and then it probably is something else. Okay, cool. That was this part. Then we have the same for comments, which is up here. Token type comments, and the end is GBA find end of line in the same buffer, but in offset +1. Okay. Then separators. That would just be offset +1, because it's just one character wide. And I think the same is with LF, exactly. Cool. But this is where we need to stop. So we return can I do that? Yeah. So end of file reached. So this is also the end of the line, technically. Nah, it's just the end of the line. Okay. And here, cool. And then we have the same thing here. Except that we need to look out for the next character. So next would be offset +1, and if next is smaller than buffer size, and buffer data next is GBA token new line LF, then offset is next. Right, and the end will be the offset after that. Yeah, cool. Okay. So now instead of a stream, so to speak, where we just get the next token while we iterate through it, we have a function where we basically fill in the token buffer for that particular line. So let's use that. Move token over here. And that would look something like this, we have a GB token. Hang on, did I even import this? Probably not. Include GBA token.h. We have tokens, and we can define something like, oh, I don't know, define token buffer size. I don't know how big are tokens even. Let's say 16 tokens for now. And then we call GBI get tokens from line. We do this on our input buffer is what we call this, I think. We have our offset, which let's see. Offset. We have the tokens, which will be this gentleman right here. And the max tokens will be token buffer size. Okay. So if this succeeds, we have all tokens of a line. Otherwise, we have too many tokens in one line. GB token is undefined. Really? Oh, GBA token. Okay. And this is where I changed my mind again. Because we want to figure out how many tokens we have actually filled in. So something like this. And instead of return true, what we return is just the current index. Same down here. And same here. And if we have more tokens than allowed, what we should return is just 0. let's do a quick error. Too many tokens. And I don't know, printf, we read this amount of tokens. I should probably let's call it token count. Okay, why is that needed? Well, because I need to set the offset to the tokens that we got, the last token, so token count, hang on. So this will return the last token count. Oh wait, if this is 0. Ugh. Oh man. Right. Okay. And that would be the end position. Okay, cool. I'm not going to print out which tokens we found. I just want to know the amount of tokens, right? So this is our input file. So I guess we go over line by line, right? So, okay. And we have build errors. Why? Because we have a find new line function down here that I'm not using. Cool. Go away. No, still not. A? Of course, this is C, ladies and gentlemen, so that function definitions need to come first. Let's just switch that around. Fantastic. Look at these hacker skills. Amazing. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines. 1, 2, 3, 4, 5, 6, 7, 8. Wait, okay. Could have just looked at the number instead of counting, but whatever. Okay, hang on. So 4 tokens. 1, 2, 3, 4. This is correct. 10 tokens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Correct. 1, 2, 3, 4, 5, 6, 7, 8. Correct. 1 token, which is the new line. 2 tokens, correct. 1 token, correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. Wait, what? Am I dumb? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, I forgot about the spaces. 10, 11. Okay, cool. And we have 2 tokens, right? And this basically has nothing because it is the end of the file, so this is why I'm not seeing this. Cool. So that works. Now we're filling up the input buffer, and what we could try now is 11, 12, 13, 14, 15, 16. Okay, that still works because our buffer is 16. Now let's add another one. Let's just do some white space. Too many tokens! Oh dear lord, why are we stuck in the loop? Holy shit. Of course, because we don't set the offset right here. Well, really what should happen is return exit failure, because like this is a no-no. We have too much, so stop it. Oh, funny how that old output still was here. Okay, so we're reading all of these and then suddenly too many tokens, which is fine. You can set this to whichever size, I don't know. Let's see, what is size of GBA token T? 24 bytes. I don't know. Honestly, I think 16 is like fine. I'll just do this, whatever. What is it? Assuming we do not extend the token struct for now. But let's just set this for now, whatever. So we don't need to worry too much about this, to be honest, because like this will be an assembler anyways, so the amount of tokens will be quite small, right? The only thing is like we could have lots of white spaces in here. Actually, let's like the craziest line could be like we have a label, right? So followed by, I don't know, let's say LDA. Then we have a register. Then there's something like this, right? I think, let's see, I have the operation somewhere, right? Instructions. So there's these. Yeah. Okay. So something like this, whatever. Doesn't matter if this is correct or not. We could have lots of spaces here or here or here. Doesn't matter, right? This probably is invalid, so let's not do that. We could have loads of spaces here, followed by another loads of spaces. We could have a comment if necessary. So this is like the craziest line we could ever have. So that would be 1 token, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then a new line 16. Wasn't too bad with my first guess with 16. Nice. Well, I'm saying that now, but there might be some other crazy things like let's open the browser. I had this hello world thing here, right? Don't know how often I've downloaded this file already. 3 times, I guess. So there might be things like these. So be 1, 2, 3, 4, 5. Yes, I don't know. Hmm. I probably have a slightly different syntax of these DB things anyways, but I mean, since this buffer is living through the whole program, we can probably just increase this to like, I don't know, 255 or whatever. Doesn't really matter. Oh yeah. Okay. I just want to check that the error handling works, that's all. So what if we have a completely empty file? What happens? Excitingly, nothing. uh, if input file size equals 0, nothing to compile. Assemble. Let's put this in fputs. Oh, how was that again? Was it like this? I never remember. Oh dear. Wait, that is here. Puts and put WS. Fine. Into std arrow. Oh, and this should be a white string. Nothing to assemble. Let's say empty file. And then we want to return with exit failure, I suppose, because, I mean, what are you trying to assemble an empty file, right? Is kind of a failure. So, although I might decide to change this later on to just spit out basically a 0-padded ROM file of 32 kibs. I don't know yet. Figure it out. File is empty. This is tokenize the file line by line. So really what we want to do here is change that to if token count is 0. Then we probably want put WC. Correct, yep. Uh, to, 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 mm, I probably want wprintf here. No, fwprintf. Okay, and this goes to standard error. Did I put punctuation in the messages before? It's a bit aggressive, isn't it? Let's not be too aggressive. Grash. Maximum amount of tokens reached in a single line, and the maximum amount will be token buffer size. Okay. And then really what we can do here is process tokens. Well, to do process tokens, right? Okay, let's just check if this still works. So let's make the token buffer size of 1. La, 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 la. This should already fail. Oops. Bang, maximum of tokens, 1, reached in a single line. Okay. If you're wondering whether this is too restrictive or not, the C standard actually specifies a lot of maximums as well for certain things in parsing. If you look through the standard, you can actually see that. I don't have the PDF of the standard on this machine, I think. Otherwise it would have shown you, but there's definitely limits as well. I mean, and you kind of want limits, right? Because otherwise someone could, I mean, would that really be a problem? Probably not, but like someone could just have like one ginormous line of like text, and your program would suddenly eat up system resources left and right just because the parser is just trying to parse and parse and parse and parse and parse and parse and parse, right? So at some point you just have to be like, nah, let's just give up. This is too much. Okay. So now I have an array of tokens. And I'm not going to go to the step of interpreting the tokens just yet. Although, I mean, we technically could. Let me think about this. So really, with the amount of tokens we have, nothing stops us from like trying to parsing all these. It would just work. I mean, probably need to have these. So indirect open and indirect close, because this operator is like an indirection operator. Basically, it means instead of the value of HL, what HL is and all this kind of stuff, I'll try to explain this once I'm actually implementing, like parsing these and things like that. We need to do a little excursion of how the Game Boy CPU actually works, right? To understand all of these. But let's just say HL is able to contain a number, and usually when you have like add A to HL, right, it would mean add the number HL to the number that's stored in A. But because you have these indirection things, it just means actually this is an address in memory, so whatever HL is pointing to, you will add that to A instead. Might be a bit confusing, but so the stupidest way to check for all of these commands would be like a string compare, right? So let's say, just as an example, I could be like, okay, tokens, whatever. Let's take this token. Let's name this and so similar as before with the string buffer, we copy size in bytes is 256, and the source would be input buffer, buffer dot data. The index would be tokens. I don't know whichever token we add. Let's just assume it's the first token. So token 0 dot start. And let's just make it this way. And the maximum count would be tokens 0 dot end minus token 0 dot start. Actually, okay, let's do it this way. Let's just iterate over all the tokens that we got and just print them out so I can explain something. So this would be token count. And for, let's just say GBA T token we're setting to tokens I. Is that correct? I think so. Then we copy this in there with token start. But only if token type is of case. Token type word. And then wprintf. There's this again. How did I do this last time? You'd think I remember. Did I just use printf? Can't remember. I think I just used printf. Yeah, okay. So for every word token that I have, like such as this, right? We kind of need to check if that is a known operator or known operation. Let's put it this way. So an operation is a thing like add or ADC or SBC, right? XOR, all these kind of things, or LD. So let's say we have LD, right? Or LD, or add, or add, right? It could have different capitalization as well, depending on what people might prefer. So one way we would have to check all of these things is to like say, well, if string compare string 1, which is str buffer, with string 2. So in this case, add, right? We found an add. If this is not the case, then we should do an else if and check it with the lowercase. And then we found an ad. So really this, right? And they would have to do the same thing, like the string compare, for every single operation that you operand that you have. Which is kind of tedious. It would be like huge code. It's not wrong code or anything. I could definitely go down that route. Just have a bunch of huge if else's that like just compare these things. It wouldn't be slow or anything. It would still be fast enough, I think. And I don't know. I might go down this route for a start. Or what I do is I have some form of a hash map, right, called symbols. Have a symbol struct somewhere where we can define what kind of symbol that is. So whether it is an operand or if it's a register or whatever, you know, or if it is a user-defined symbol. And then we can just calculate the hash of the string here of the word token, and then just look up the symbol in the hash map, and then we know what it is. The benefit of this is I could then later you know, if someone is using the assembly or I'm using the assembly and I decide for some reason, let's say, I don't know, I do not like I don't even know. I don't know. Anything, right? I do not like using bit. Bit is confusing to me. I don't know what bit means, right? I could have something in assembler where I could be like define or whatever I want to call it, right? Where we have some other symbol name, something like my cool bit operation is bit. And then all we can do is add this to the symbols hash map and set it to the exact same symbol struct that we have for bit. And now everywhere in the assembly code, instead of bit, I could use, you know, this define for basically override the name to whatever I like, what I prefer. Or let's say I don't like LD, I want it to be more descriptive, so I want to use load instead, right? So I can just use load, AB, CD, whatever, you know. So I kind of like the hash map idea, but that means implementing a hash map in C. Which I have never done before. But it could be fun. I wonder how other compilers are doing it, or other assemblers. Keep in mind, I have not looked at any other code, so I don't know what other assemblers are doing, how they're built, or anything like that. One reason why I haven't looked at other assemblers or other code is because I don't want to get influenced I kind of want to try and see if I can come up with my own solution for things, if that makes any sense, you know. Um, I don't think anyone would write an assembler like this, anyways. Probably have some auto generation tools where you have like some language syntax that you put in and it spits out the code for you, and yeah, don't need to worry about it, I guess. But where's the fun in that? I'm here to learn more programming after all, not to use other people's tools. He says while using Visual Studio. I get it. The dog, currently on the bed, pooped. I mean, she didn't poop on the bed. She's pooped, as in she's exhausted, just sleeping. Took her for a long, long walk this morning. I think we were out for like 4 hours or something like that. So she's absolutely dead. She didn't walk the whole time. Obviously, I have a little carrier bag sometimes because it's a tiny dog. All right, so oh dear. Do I go down this rabbit hole of implementing a hash map and see? Hash table, hash map, what's the difference? Cuckoo hashing, nice. What's like a good and easy, straightforward hash function to use? I should have probably thought about this beforehand. this will probably be a very quiet section. I mean, one thing would be using like a already existing hash implementation from someone, but I wouldn't even know which one to look for. I remember I had something bookmarked on the other machine. Give me a sec to look that up. Okay. So there is I had this one saved up. Well, wrong keyboard. So Fowler null Rio hash function. There's a Wikipedia entry for it. Okay, I'll just try and use this one maybe. I don't know about the bucket size and things like that, so are there any other links to other hash functions? Non-cryptographic hash functions. Okay, there we go. Maybe I can find some other one. Pearson hashing, 8 bits or more. XOR table, what does that mean? Executes quickly on resource-limited processes. Yeah, I mean, because it's very simple, right? There's no simple class of inputs for which collisions are especially likely. Given a small privileged set of inputs, reserved words for compiler. Interesting. Okay. This is kind of fun. Never heard of it before, but it's cool. Which one is this? Was rolling hash. I don't really need a rolling hash, do I? So there's this one, okay, which is what I have open right here. Jenkins hash function. Okay. I mean, I know about XX hash and all this kind of stuff, but that is a bit too much to implement for what I'm trying to do, isn't it? I mean, the hash function itself can later be changed, right? I just need something to start out with. So Pearson hashing might just be alright. Hmm. I think I'll try this. Why not? One second. Okay, let's read this section again. So if I use this, then the table would be relatively small, right? It's just an 8-bit hash, and which means 256 different values I could possibly store. Well, obviously a bit more with collisions then, and then, but that would at least be enough for all the keywords that I wanted to check. Because there's not that many, right? Um, I have the keyboard on the wrong machine. Hang on. There we go. There's not that many all in all, right? Uh, these names are fairly given because of the registers that we're having. There's not that many. And to be fair, these could be yeah, I think, no, this is okay. This should be fine. And I'll just copy the, the table right from the paper. Why not? Why the hell not? Well, there we go. Okay, let's just, I'll just do that. I'll just do that. It's gonna be fairly simple. Okay, let's do, it's funny that this is C sharp. My background at least, and please don't do this. This will create a copy of your array, don't. Okay, what we should add is a new header file. called GBA hash dot h. Yeah. Okay. And what we want is a const byte table, right? Is that it is unsigned, right? Yeah, it's a byte, so it is unsigned. You know what? Let's do it like this. This would be what should we call this? Permutation table, whatever. Of 256. Right, I need to include my library for this. Let's just do this. Okay. I'm not sure if I'm allowed to do this in C. Can I just... is that possible? Yeah, let's get rid of this code. We don't need that. Yeah, okay. Okay, cool. Let's just copy these values. Why not? Great. Oh dear. Nope. You know what? Nope. Not going through that insanity. Where's sublime text? Cool. There we go. What? Those were too many. Really? Interesting. How? Oh, I have some empty. Okay, There you go. Weird. Must have screwed something up there. Okay. And then basically have this little algorithm right here, right? So let's say we want a U8 compute hash, and the input would be a const yeah, let's do U8 because that's what we are reading out. I mean, not that it matters that much anyways. Yeah, value. Okay. And then we're going through well. What? You think this is wrong? Okay. Not sure if you heard the dog bark, but what I probably want is also the count of the values, because those strings, those values won't be null terminated, right? So for and then what we have is U8 hash, and this would be hash equals too easy to type. And that would be hash x or value I. Okay. All right, let's do a little comment in here, because I need to check if I have to give credit somehow to the, I mean, should probably give credit since I didn't come up with this shit on my own, because I'm not good with this sort of thing. So if I would like to test this now, let's do a little test function, which we'll run on top of everything else. We do not care about any of the outputs there. This is fine. Let's leave the file empty. Yep. Okay, and we can make this full screen again. Actually, no, let's not make this full screen, because I probably need to copy all of these instructions. Actually, I think there might be a table of all of the names somewhere in this programming manual. Yeah, this should make it a bit easier. I will be using that. Sorry, I cannot show that, but what I'm having here is the official GameBoy programming manual. So I'll be just using that for all the possible names of things. And what we're just going to do is have a printf, and to see what hash we're getting, dumbest way to print this out. Names will be never that long, but whatever. And we have a U8, which is the hash, right? And then we'll have some sort of array here of some unspecified size. Well, we'll add the, yeah, it's empty, it's invalid, I know. I will be fixing that shortly. And then we can say I think this should work. Maybe not. I'll figure that out in a second. And then we just print send s for the name and the hash we're getting, and that will be values I dot name and values I dot hash, right? And then we can say, okay, the name will be whatever, and the hash is, oh, what? I cannot do that, can I? Okay, that's fine. I'll just have a fixed number, and then just do it like this for now. Okay, this will be that, and computer hash. Which was value and account, so let's just add the same name, whatever, and the count of however many characters we want. Does this work? Expected an expression. Do I have to specify it like this? No, I don't, so what's wrong? Does it have to be .name and .hash? Nope. Okay. Does that only work for initializers then? C. Wait, what if I do... No, that wouldn't do it, obviously. Okay, fine. Okay. What? I forgot how to see. Jesus. What? uh... So that. Okay, I give up. I have to look it up. Wait, that's what I was doing, no? Okay. So can I do this? Oh, that works. Okay. Cool. Of course. Let me do breakpoint real quick. And if I do size of values here, it is the actual. No, what? Let's add a second one. Okay, that works. Okay, so size of values divided by size of test t. That is the array size. Okay, cool. I know this is quite a long setup for just some test code, but it will make sense in a second, I hope. Okay, so basically, what do we have? We have LD, right? Okay, there's a lot of LD in this. LD, 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 LD. Okay, we will have push. I'll change the hashes in a second. I just want to write out. In fact, let's do this. Whoops. Okay. So LD, we have push, we have more LD, we have pop, we have LDHL. Okay, more LD. Why did you list it that way? I don't know. We will have add. We have ADC. We have sub, and we have SBC. We we have and or XOR CP inc deck. Yep. We have more of those. We have RLCA, RLA, RRCA, RRA, RLC, yeah, RL, RRC, RR, SLA, SRA, SRL, swap. Don't worry what all those mean for now, but those are basically all the different operations that you can give the Game Boy CPU. Well, I say all of them. No, the table was just weirdly broken up. There is more. Okay, I was about to say that seems a bit too little. Okay, whatever. So, swap, then we have bit, set, res, jump, JR, call, reti, RST, DA, CPL, NOP, CCF, SCF, DI, EI, halt, and stop. Cool. So I hope that was... Yeah, that seems to be all of them. Now, those are the operations at least, but then there's some other names that we need to account for, and that is like condition flags and stuff like that. So we have NZ, NZ, Z, NC, C. Right. Right. Then we have registers. Wow, that NC and C is annoying because C is also a register name. So we have A, B, C, which is up there, D, E, H, L. Then we can form register pairs out of these. So we should probably add those as well. So we have BC, DE, HL, SP, and in one instance AF. BC, DE, HL, AF. Yes. A, B, C, D, E, H, L. Is this everything? Should be. Okay. So we have the hash of LD, which is 2 characters. Push 4, pop 3, LDHL 4, add is 3, ADC is 3, sub SBC, and sorry. I was thinking if I should apply a better way of doing this, but honestly, actually, yeah, I could apply a better way of doing this, couldn't I? Yeah, okay. So compute hash. Let's remove that. Let's remove that, and we're just setting it to 0 for now. Right. Take this, copy, paste. Okay, we have the values. What we can do is first up, int. No, let's do size t. Count. So this is how many elements we have in the array, right? We should probably change this to size t as well. Let's just do the computation as part of this one. Why bother, right? So we can say compute hash, and we can have the value, which would be, I don't even need this hash entry here, I just added it, whatever. Trying to overcomplicate things, right? So we can just have i.name, and then the count would be string len. There we go. That should be okay for a test code. And let's print out the count as well. Printf array count would be this count. Probably do not forget the new line, neither on these. Okay. Are we good? I think we're good. Okay. Fire in the hole. Cool. So 59 keywords in total. And there we have the hashes of all of them. Which seems to be pretty good. And then probably what we would also want to add is the same ones again, but lowercase. So and it also is a different hash. Very nice. Okay. Well, now with this information equipped, we can sort of try and build the hash map now. So let's go ahead and open GBA hash. And actually, let's do this the other way around, sorry. So what does a hash map need? Well, exactly the same thing as the test struct, really. So we need a type def struct. Actually, let's call this GBA compute hash, just to follow the already set out, naming conventions. So this would be GBA hash entry table entry, I guess. That's more like it. So we have a table entry, T, sorry, GBA table entry. Structs is what I like to name them. And then we have, for one, the value. So char value. Now let's do it like this. We give it a fixed size because, I mean, the largest one is 4, I think, here. We can all adjust this later on, if necessary. If we would like to mix, so this is not for the symbol table, as I mentioned before. This is purely just for the operations. For the symbol table, we would like a hash table as well, and I have to think about a bit more, like what kind of hash table or hash function I would like to use there. So I'm not going to worry too much. This is like a nice good test to actually get the operations working, and then we worry about, symbol names later when it comes on, and maybe we can combine those tables together then into a nice single hash implementation, hash table implementation. So here we have hash. Right, so we have the value and we have the hash. This is what we want to store in our hash table. And then we have struct GBA hash table, GBA hash table T. And what do we have there? Well, we have table entries, and how many do we have of them? Do I even need? So this doesn't account for collisions, 1. And I'm wondering if I even need the structs, because a hash table just becomes an array. Right. So let's not make an extra struct right here. Okay. Right. Then we want the table itself. So I'm just gonna sneakily copy this. Hang on. What am I trying to do? Actually, what I should do is now extend this little test here and spit me out the table with the calculated hashes and the names, so I can just embed this into this file, right? So let's do that. Oh, just got a very loud notification. Sorry. Okay. Okay, that's sorted. Okay, so let's do that. I'm not gonna bother with register names for now. And these, let's just do the operations, right? And okay. Let's just do this. Cool. Whoa. Okay. Whatever, doesn't matter that it's not aligned, but OCD, right? So LD, push, let's just do that in lowercase as well. Why not, while we're at it? Alternatively, what I could do, I could convert it into lowercase or uppercase with the C library, I suppose. Yeah. Okay, let's just do the uppercase ones then. So if you would be doing lowercase, it would be a little bit slower, I suppose. I can add the lowercase ones later on if I really wanted to. It's kind of weighing on my mind now, though. No, let's add them. Okay, sorry. Push. Then we have pop. LDHL. Add ADC sub SBC. Almost done, almost done. JR. Call. Return. Return again. DAA. CPL. No. CCF. A. And halt. And stop. Yeah, we should maybe stop. Okay, cool. Fantastic. So we have the values. And now what we're doing is values I, then we compute the hash on value I, and the function name changed, which is GBI compute hash now. And really what we want is in this syntax, right? So we have value, and comma dot hash like this, and a comma, right? I think that's correct. Excuse me. What? What do you mean 2? What? Oh. Cool. Yeah, so that happened. Never mind. Don't look at it. It's all good. It's all good. Nope, that was also wrong. Shit. Like this. Yeah. Cool. Okay, now I can copy this. Sweet. And can make our table. So this would be const GBA table entry T operations table. Why not? GBA operations table. Bam. Now, I haven't checked for any collisions. Hang on, this is not what the table is. What am I doing? These are the values, right? But now I need to put them in the correct positions. So, brain fart. Okay, hang on. What are we doing there? Well, let's make this quick and dirty. He says, and then his brain stopped working. Shit. Ah! So the hash value determines in which bucket this thing lands in. So what we really want then is, let's just say malloc for now. Sure, we have count times size of GBI table entry do I need to make that complicated? Yeah, sure, why not? GBI table entry, yep. So that would be GBI table entry entries. Let's cast that to this. So however many we have here is however many entries we need. Cool. We just allocate that real quick, and then let's not forget to free it. Okay. So, and then U8 hash, right? So we're computing a hash of something. Can I do that? Can I say 0 memories of something that has been allocated like this? Let's find out. Build errors. What? True. Hash. Cool. Seems to be working. So entries should all be 0 and 0, 0, 0, 0. Okay, so there's 0. Oh, but not quite what I wanted, is it? No, this is fine. I can figure out whether something is not or not that way. Yeah. Okay, so, and then I want to get the table entry. And the entry will be in entries dot hash. Right? And then if entry value 0 is this, oh, if it is not this, then we have a collision, right? There's a collision, and we're going to investigate that one. So actually, let's not make a breakpoint in there. I want to see if this even gets printed out at all. And if this is not the case, then we can fill stuff up. So we can say entry this is for later. Okay, so entry hash equals hash, and then entry value equals, well, okay. String copy, why not? Entry value, and we want to copy values I. Okay, cool. So this is how we fill up the entries, and then all that's left to do is finally print out the entries. So for size t I equals 0, is small count I plus plus. So now they should be in the right order. Because we're just gonna do this, where we then say, yeah, so, and what do we want? We want the, okay, this is still correct. So entries I dot value, and then entries I dot hash. Right? Dereferencing null pointer entries. Sure, if entries is null, then whatever, return. Can make a breakpoint there, but that won't happen. String copy is unsafe. Do not use string copy because string copy is unsafe. Yada yada yada. Okay, fine. Entries value is 4, right? So let's do 4. There we go. Happy now? You're happy. That makes me happy. And we have an assertion failure. So what did I do wrong? Ah! Hang on. Oh, really? No. So we're going through all the elements, through all the values, calculating the hash of that value. We're looking in position entries plus hash, getting a pointer out of this, which is correct. And then we have the value to check the first entry of that value. Okay, so where are you? So we have string copy. Why? What is values I? That would be LD. And we're trying to copy this into here. which presumably worked. Okay. The next value would be lowercase ld. Our entry a. Did zero memory not work? Okay, screw this. I'm doing it myself. And then what we're doing is entries I dot value equals there. This is the important part. The rest I do not care about. Is this not a modifiable value? What are you on about? What am I missing? Am I being dumb right now? Welcome back. What? Oh, is it just because of this? Right. Okay. Fine. I'm confused as fuck right now. Of course I'm confused as fuck right now. Oh my god. No, that it doesn't explain these values. Okay, I have to think about this some more. I'm just hacking around at the moment, which is not great. How to see, ladies and gentlemen, I have no idea. In case you haven't noticed by now, I'm kind of new to C. Okay, so the count would be, I mean, this count is correct, right? We want a GBA table entry. And what we would like is to allocate 256 different slots in the size of GBA table entry. We return that as a pointer, which is fine. I mean, if it's a fixed value, why am I doing this even like... why so complicated? Why was I even using malloc? Where was my brain at? Just 256 entries. Right. It's just all 0. And I don't think I even need to do this then. So we have entries. And will you look at that? They're all 0. Fantastic. So we don't need this step. We have the array count. Yeah, we're computing the hash. Then the entries. Actually, we can just get... let's just make this code even simpler. Why the hell not? So entries hash dot value. And we're just checking the first character. Entry hash dot hash equals hash. This is a beautiful line. You can never have enough hashes. Then we have entry hash dot value, where we just copy the string like so. And then entries down here, actually, we want to print out 256 of those, because some of them will just be 0. And buffer is too small. Oh, this is for the string copy. Okay. Let's see. Why would the buffer be too small? Because it's probably trying to attach a null termination. And indeed it is. So let's just set this to 5 properly then. Because I forgot about the null terminator. Okay. Nope. String copy is still kind of fucked up. Okay, let's see. So hash is 18. So value 18. There we go. What? Okay, let's what am I doing here? Oh my god, that doesn't make any sense either. Jesus. Entries hash. That's what I want to do. And then it's 5. And we want to copy 4. Correct? Okay, so what's hash now? 18. Entries 18. There we go, now it works. Good god, what was it doing? And we indeed have a collision. What is the collision? 40. Hash is 179. Which is LDHL. And it collides with what? With values 40. With RRC. Okay. How many do we get? $11 collisions. Well, that's a good start. Okay, so one way to avoid the collisions, I suppose, would be to play around with the permutation table a little bit. And right. I mean, I have been going on for 3 hours. So I might be stopping here for now. But you can sort of see where this is going, right? Let's just... So I need to resolve these collisions. I have to have a think about it, maybe see what the permutation table, how I can adjust it to avoid collisions with the given values that I have here. But what this code would be producing is like this output right here, which you could then basically just copy paste, right, and put this in here as our table. So now we just have a hard-coded hash table with lots of values being 0, whatever. Actually, I realized I do not even need to store the hash in there with this hash table, because like the entry is the hash, I suppose. Yeah. And then, anyways, I mean, what I can quickly do is imagine this table worked. What we would do here is if we have the token type word, right, we would then try to compute the hash so of the given word. So let's say u8 hash equals GBA compute hash. The value would be the input buffer dot data, and it would be in location token start. So this is where our buffer starts, and the size would be token end minus token start. So for any given word, we would get a hash, and I mean, yes. So and then what we could do is we can go in this table in this exact position and ignore the hash for now, but then we have value here, and then we do still a string compare, right, like so, with, you know, whatever string. We need to use this version though. Let's do compare s, no. Just strn compare. With this thing. And the maximum count to compare again would be this. So ideally what we should probably do is have a uaint pointer to the value start, right? So that will be this. So we can say value start here, and then we have the count, which is this value count. Yep. And if the values are indeed correct, we have found the right keyword. Otherwise, it is unknown, right? So we could probably test this with the values that are in here right now, since I just ignored the collisions. So let's say, for example, but I hope you can see what the benefit for this is. Instead of having string compare with every single possible command, right, and this huge if-else, we just need to compare it once. We compute the hash, look up what's in the hash, and then actually see if it is the same. I'll probably use some other proper hash implementation, to be honest, because like I want to have this mixed with symbol names, as I mentioned before. But let's just test this real quick, right? So printf. Actually, let's just do puts. This is a valid keyword, and then here we have puts. This is invalid. Cool. So let's comment out the test. And then let's say, so if we have, no, this is the wrong file. We are going to program gbasm, and let's say we have pop. Why not? Pop. And then we have something that's definitely not in there. Hello. Although that might result in the same hash, I don't know. Actually, so you can see what actually happens if there is a collision. Let's just fire up the test real quick again and make a breakpoint here. Because that way I can check one of the collisions. So this is, what was it? Values 40. Here, which is RRC. Okay, so 3 different values. And let's comment out test again. And let's make a breakpoint here so we can actually step through with this. So we should get 3 word tokens, basically. And yeah, so we're computing the hash of the first word token, which is 3 characters long, which is correct, which is pop. So we go into the next line. We look, so our computed hash is 83. 83. So why can't I see the table? Let's add it then. There we go. 83. And indeed is pop, right? So this string compare should work, and indeed it does. So we actually have found a keyword that's valid. On to the next word, which is hello. I'm curious what's going to happen here because I have no idea. Hash is 143, right? So we're grabbing the value here of 143. And as you can see, the value that's stored in there is SLA, so this string compare will fail because even though the hash is equal, the value is different. So this is an invalid keyword. We don't know what this is, right? And then, I mean, I put RRC in there as a comparison, but it basically happens the exact same thing. So you go through this, calculate the hash of RRC. Yep, RRC. It's 179. Where is it? 179. But what's stored in there is LDHL. So this comparison will fail as well, and this is an invalid keyword. But since we know this is a valid keyword, we actually, should be able to use it. One way traditional hash maps would solve collision issues like this is, well, there's multiple ways you can deal with collisions, but one of them you could imagine could be like, let's say it's like a linked list, right? So there's an entry to the next item. So then in one slot, you suddenly can have, multiple of these with the same hash. And then you would just follow through the list and string compare with all of these, basically. That's one way you could do it. The other way would be like, okay, you have a collision, so you just do hash plus 1, see if this is empty, and then just put it in there. Which results in sort of the same thing because you still need to, do all these different comparisons all the way down until you actually get to a value that is the same. But I think I can make this table collision free, right? If I just kind of figure out the permutation and stuff. I'm going to read the paper a bit more, or maybe just look at the different hash implementation altogether. Just have to think about a little bit what I want to use there. And since I'm not too familiar with hashes, I never implemented my own hash map or anything like that, so it's a bit of a challenge for me at the moment. But hey, you learn something new every day, right? I come from a C# land, and I usually just used whatever implementation was available to me. So anyways, I think this is where I'm going to stop. Didn't make as much progress as I wanted to. So we refactored the tokenization a little bit. Right, I think that looks a bit neater. and then we just faffed around with hash. uh, I'm not sure I will be able to stream tomorrow as I have some other commitments I need to attend to, but I'll try to maybe come live for 1 or 2 hours anyways. And hopefully I have a solution for the hash stuff by then, and a table that actually works without collisions. Anyways, that's it. Thanks for watching. Again, I'll be uploading these videos on YouTube as well. If you just search for my same username as on Twitch, you can find me there as well, and then you can watch the recordings from previous streams. And that's it. Thank you. Bye.